Hello, my name is Robel. The title of this presentation is Cursor Accessibility and Tutorial Videos, and of course that's the topic of the presentation, and it's my final project for the computer vision class. Um, so kind of the issue that this project is solving is is basically there's a lot of tutorial videos out there, right, that make people's lives better. They show us how to do things, but sometimes the cursors, at least for me, can be hard to follow. Maybe someone's moving a cursor quickly, they're going through the steps really fast, and sometimes you have to rewind and see, where did that cursor go, or what button did it click? And in our own personal use, right, if we're using a cursor, we can make our personal cursor bigger, right? There's add-ons and things that you can use to do that. But in a video that's already been made and exists and is uploaded to YouTube, you can't change the size of that cursor. So it's sometimes you have to keep rewinding and seeing where the cursor goes, and that can lead to frustration, even in myself, and for people who have maybe worse vision than me. That might cause you to give up, right? If you have to look too hard, and you might just say, okay, I'll find another way around it, right? Or I just won't do it, whatever that task is. So, kind of a solution to that problem that I encountered, or thought of when I encountered this problem, was we could make an algorithm that takes a tutorial video with a cursor as an input, and then spits out an output of like that same tutorial video with a bigger cursor in the same places that the smaller cursor was, right? So then you can see where the cursor is going with no problem because it's a bigger cursor. And this is really related to computer vision because we have to be able to detect, where the cursor is, right? So when I was working on this program, I chose to use this video, this PCB design video, as part of a class that I had to take also at OU. And this video actually was the reason I thought of this problem, or this project, because it was hard for me to follow along sometimes, as Dr. Bully, the author of this video, moves his cursor pretty quickly. And also in PCB design, there's all kinds of shapes. So this is a great video to test whether the algorithm can differentiate between a cursor or different shapes. So this is the video that I chose to use, but I didn't use the whole video. As you can see, it's about 2 hours long. So I chose to use a short snippet of this video, and let me play this short snippet. This is the video that I tested the algorithm on. And you can see the cursor is moving around, and there's no audio, but I guess the point is to classify or locate the cursor, so audio isn't really needed in this initial testing stage. But so, and then this is kind of the result or the output of the of this algorithm, right? You can see the cursor is a bit of a different size, and if I play the video, you can see that the cursor is still big, right? It's a little bit bigger than the original cursor. And then as he starts to move the cursor a bit here in a couple seconds, you can see that large cursor sticking with it. And you can also see in some places there's a blip, right? It's not, it puts the big cursor somewhere else. And in that final frame, it's put it in the wrong place. But for the most part, it follows along pretty well. So let's get into how exactly this was done. What are the methods of this algorithm? What are the steps? So there's four main steps. The first step is to remove the irrelevant information, so in the frame. So this is, by the way, this is processed on a frame by frame basis. So the algorithm takes the input video and breaks it down into frames, and then processes each frame individually. So if it finds the cursor and replaces it with the bigger cursor in each frame. And then it takes all those new frames, combines them, and outputs the new video. And these are the 4 steps involved in processing each frame. So it removes the irrelevant information. So there's a ton of information, shapes, and lines and things, and you want to be able to get rid of some of that so you can find the cursor easily. So that's the first step, is to remove the irrelevant information. The second step is to reduce the search space, right? So find all the places where the cursor could be, possibly. And then the third step is to decide on the cursor location. So out of all those possible locations, which is the most likely? And then the fourth step is just to place the new larger cursor in that cursor location that you decided on from step 3. So let's go through each step. So the first step is to remove, like I said, the irrelevant information. First, you can translate or change the RGB picture or frame into the grayscale frame. So you get rid of the color information. And then also there's kind of another step called the edge finding step, where essentially we see if we're moving from left to right or right to left, where are the highest increases or decreases, or I guess changes in intensity in these pixels, right? So what basically we're doing is we're saying from 53 to 229, and by the way, this is the cursor here, from value of 53 to 229, if it's above a certain threshold, let's say 100, then we can identify this as an edge, right? So we're going through each of these rows and finding all those significant edges. And as you can see, even if there's a black background, the white on the inside of the cursor versus the black on the outline of the cursor already creates that edge. So it doesn't matter what background we're in, that edge will always pop up for the cursor. So it's a reliable way of making sure that the cursor, or detecting where the cursor could be. And so this is an example of that. I chose a random frame to do that in. And as you can see, after you run it through this first step, the information is reduced, right? So these pins and these capacitors don't really show up in the reduced information frame, and the cursor is still there. So we've kind of reduced the irrelevant information. And we do this, like I said, for each frame, and there's usually about 30 frames per second. This is a couple other examples. So once we've done that, we also want to reduce the search space, right? We still don't want to search each pixel. So the second step is to find all the vertical lines or the vertical edges that have a length that is similar to the cursor's height, right? So we don't want to take lines that are, for example, go through the entire screen, because that's not how big the cursor is going to be. So we're looking for a certain size. So this further reduces which of these lines could indicate, or which of these locations could indicate a cursor being there. And we're getting the location of the tip of these vertical lines, so we can find the location of the tip of the cursor. And that will tell us where to put the bigger cursor. And we're looking, by the way, for lines between 13 and 20 pixels. But this also changes based on your resolution. And to save us some time, we're looking through the non-zero columns. So a lot of columns are just empty columns like this one, like these. So we don't want to waste our time by looking at those columns. And this is an example of when that kind of search might not work. Whenever the cursor kind of lines up with a border or an edge, then you might get a line that's kind of continuous like this. And if we're looking for lines that are between 13 and 20 pixels, we're not going to find this. And in this frame, the cursor is going to be, it's not going to be located correctly. So, but most of the time it does work. That we'll talk about that in the future directions, but that's something that we need to work on. But step 3 is to locate the cursor. So we have a list of possible locations, right? So we've got, and these, by the way, this other number is the length of that line, right? And this is the location of the tip of that line. And so this is an example of some places that could be detected as the location of the cursor. And so we want to be able to choose between these, right? Which of these is the cursor? So the way we do this is by comparing the ideal shape to the shape at that given location. And we do that by subtracting the ideal shape, or sorry, subtracting the shape at that location from the ideal shape. And we'll get an error matrix, right? So kind of the difference between that shape and the cursor shape. And we get kind of the sum of those errors. It tells us how similar the shapes are. And the lower that error matrix is, then the better chance that it is a cursor. And as you can see here on the right, these are some examples of what the scores could be. And this cursor, the actual cursor location will most of the time give us the lowest score. And so this step in the algorithm takes the lowest score, the location with the lowest score, as the location of the cursor. And so then the final step is to place the big cursor in that location. So as you can see, this is the original frame and this is the new frame with the bigger cursor. And you can make this cursor bigger. Here it's not much bigger, but you could make it bigger. This is an example of kind of the map. I had to generate this image manually, as you can see. So you can make it bigger also. So that's the algorithm now. I really enjoyed working on it, and I'm hoping to make it better a little bit because it could be better. So future directions could include, like I said, making the accuracy better. Right now it's at about 97.5%, which means I think about every 30 or 40 frames, there's an error, right? So it puts the bigger cursor in the wrong place. And that might seem great, but when you have a FPS of 30, which is common, then you're going to see an error about every second. And that's definitely distracting. So ideally, you'd want less less errors, and maybe a target is less than 1 error per 5 seconds, and that's an accuracy of about 99.5%. So that's a good target to shoot for, I think. And then also improving the speed of the algorithm would be great. So right now it takes about 1 second to process a frame, and that's a really long time. Like I said, 30 FPS video would take hours for like a regular 5-10 minute tutorial video. So the speed definitely could be improved on. But the algorithm does work for the most part, and yeah, hopefully it solves that problem. And we don't have to treat tutorial videos like a Where's Waldo puzzle, and things are easier to follow along with. So yeah, that's this the project, and I hope to improve it in the future.